Where do you see combinatorics going in the near future?
It's a complicated question. For example, Tim Gowers, that people respect a lot, feels that by the end of the century, mathematics will be done mostly by computers. They'll make the conjectures, they'll have the proofs, and our job is to kind of tag along and see how to apply it. You know, there's a nice story that you ask in 100 years, oh, great computer, tell me, is the Riemann hypothesis true? The computer says, okay, come back after lunch. You come back after lunch and he says, well, yes, it's true, but there's no way you could understand the proof. Well, okay, if that's the way it is. There's a certain philosophical point of view that, and there's a little more evidence to the truth of this, that most mathematical statements are kind of beyond proof of human being in the following sense. Look at one of the more recent accomplishments, say the classification of finite simple groups. You can state the problem on a page. Could you ever find a proof in 100 pages, 1,000 pages? I don't know. I mean, for example, the four-color theorem, which is a theorem about coloring maps, recently proved by computer, billions of cases, and one of the provers, Wolfgang Haken, feels there won't be any short proof. It's true because 100 billion things are true. That's the reason. Well, how would you, if that's true, no human being has ever checked that proof. Well, do you believe it? Well, if your computer program is correct, well, you can check that. If that's the case, and there are fragments of mathematics in which there are statements that are true statements in that fragment, but the shortest proofs there are doubly exponential. So you won't really be able to find a proof. I mean, there's kind of not a real conjecture in number theory. To prove that a number n is prime is going to take a number of steps that grows at least like the logarithm of n, which is kind of Mersenne prime. And now if that's true, then you have a number like 10 to the 10 to the 10 plus 73. If it's prime, you'd never be able to prove that it's prime. You can give these probabilistic tests, and it looks like it's behaving like a prime, but you never prove it. So the whole edifice is kind of shaky if you can't really prove it. And then, there's a question in mathematics, what's more important, something coming up with a conjecture or the proof? I mean, sometimes if you know what you're trying to prove, sometimes that's half the battle. You often don't know. When they tried to prove this conjecture of Euler, that you couldn't have a fourth power of an integer, the sum of 3/4 powers. And people tried like crazy to prove that for a while. And the reason they got stuck and they couldn't prove it, it wasn't true. And that often slows people down, although not everybody. And in fact, that was the theory there. And then the Nomelkes finally found examples and so forth and so on. But it's just a message that when you're trying to prove something, you're kind of convinced it's going one way, but it's really going the other way. So I have a saying I always keep in mind. The main obstacle to progress is not ignorance, but the illusion of knowledge. You think you know. No. Once you understand you don't know, then your mind is a little more open to say, oh, okay, there are other possibilities. Like maybe it's not true after all, even though you wanted it to be true.